Welcome back. We are going to now discuss the concept of rank related to matrix. So let's go through the definition first. Rank of a matrix A is the number of non-zero rows in its row echelon form or reduced row echelon form. So we have already discussed how to get the row echelon form of a matrix. We have not discussed how to get the reduced row echelon form of a matrix. So we will very soon do it. But if I ask you now to get the rank of a matrix, you just reduce that matrix to its row echelon form, count the number of non-zero rows it has, and that number will be the rank of the matrix. Let's go to an example first. Say, find the rank of the matrix whose first row is 0, 0, 6, 2, second row is 0, 2, 1, 1, third row is 0, 3, 3, 1. So I want to know the rank of this matrix. Recall, we have already got the row echelon form of this matrix in our previous lecture. So if I want to get the rank of this matrix, first I have to reduce it to its row echelon form. Now its row echelon form is this. The pivot is 2, 6, minus 1. Now look into this row echelon form carefully. First row has a non-zero entry, so it is a non-zero row. Second row also has a non-zero entry, so it is a non-zero row. Third row also has a non-zero entry, so this is also non-zero row. So the number of non-zero rows here is equal to 3. So rank of A is equal to number of non-zero rows in its row echelon form, and that is equal to 3. So now we write down the answer like this. Rank of A is equal to number of non-zero rows in its row echelon form, and that is equal to 3. Now we add one quick remark here, because we can also have an alternative definition for rank. Notice that rank of a matrix A is number of pivot entries in its row echelon form. Recall that every non-zero row has a pivot, and the first non-zero entry is its pivot. Say for example, in this row echelon form, first non-zero entry is 2, so it is the pivot for this row. Similarly, second row is non-zero row, first non-zero entry is 6, so this is the pivot for that row. Similarly, third row is non-zero, first non-zero entry is minus 1, so this is the pivot. So every non-zero row will have a pivot. So if you count the number of pivots, that will also tell you the rank of the matrix. So that's why the remark says rank of a matrix A is number of pivot entries in its row echelon form. Now let us take one more example, one more exercise. Find the rank of the matrices A, B and C. Now this example also we have discussed already. Notice that the first 4 columns of B are nothing but the first 4 columns of A. First 2 columns of columns of C are nothing but the first 2 columns of A. And how to get the row echelon form of B and C? We can get it from A itself, row echelon form of A itself. So we have done this exercise earlier. So this is the row echelon form of A. Here the pivots are 1, minus 1 and minus 9. Since the first 4 columns of B are nothing but the first 4 columns of A, so I will just copy the first 4 columns of the row echelon form to get the row echelon form of B. So row echelon form of B is the first 4 columns of the row echelon form of A. Similarly, first 2 columns of the row echelon form of A will give me the row echelon form of C. Now here the pivot is same, 1, minus 1, minus 9, and here the pivots are 1, minus 1. Now how to get, now let us see what is the rank of this matrices. Now the row echelon form of A has 3 non-zero row, or say rather 3 pivots. So rank of A is 3. Row echelon form of B has 3 non-zero rows. So rank of B is also 3. Row echelon form of C has 2 non-zero rows. Third row is a 0 row. So rank of C will be 2. Notice that a submatrix and the matrix itself can have the same rank. Here rank of A is 3 and rank of the submatrix B is also 3. This this concept will be required in later stage to solve a system of equations. Thank you.